Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 10.4, Problem 4. This is Section 10.4, Problem 4. It says, sketch a quick graph for each of the following exponential functions. And there are 9 different functions to sketch, and they start off with the easier functions, and by the end they're a little bit more difficult. So the first one is a very standard 2 to the x. So exponential functions have one of 4 different positions. It's all the same shape that gets flipped around different ways, and it has what I refer to as a big end and a small end. So for 2 to the x, that's the standard one basically. If you have a positive base, positive exponent, the big end of your exponential function is in the upper right-hand quadrant of your Cartesian coordinate system. Positive values of x make it grow really, really fast, and negative values make tiny, tiny, tiny fractions, but they're still positive. Now b is almost the same as a. b is f of x equals negative 2 to the x power. So that negative in front of the 2 is going to give you the same shape, but it's going to flip it down. So again, what I refer to as the big end of the exponential function is now in the lower right quadrant of the Cartesian coordinate system. So again, positive values of x will make it decline very rapidly. Negative values of x will make tiny, tiny negative fractions. And then part C, it's, again, very similar. You have the same parts, it's just a different part that's negative. You have 2 to the negative x power. So it's the same shape again, but now what I refer to as the big N has been flipped around to be in the upper left quadrant of the Cartesian coordinate system. So now positive values of x will make tiny, tiny positive fractions. Negative values of x will make the graph climb really fast. And part D, you have f of x equals negative 2 to the negative x. So both things are negative. Again, same pieces that we've had in the past. We're just changing what's negative. What's going to happen with this is what I refer to as the big end of the graph is in the lower left. So now positive values of x used as an input will make tiny, tiny negative fractions, and negative values of x used as an input will make the output go down really fast, very far. So now with part E, we start using what's called a shift. Part E says graph f of x equals 2 to the x power and then plus 3, where the plus 3 is not in the exponent. It's a number like the 2. What that is, that's what you call a vertical shift. So it's going to take the regular 2 to the x power that we had in part A, so essentially something with the big end in the upper right, but it's going to pick up all the outputs by 3. So now, if you start with your Cartesian coordinate system and have an imaginary x-axis at a height of 3, then it's the same shape, just elevated by 3, as the f of x equals 2 to the x. The plus 3 on the end just picks everything up by 3. Now part F is an interesting comparison. It says graph the exponential function f of x equals 2 to the x plus 3. But now the plus 3 is in the exponent. It's not on the end of the function. Now when it's in the exponent, the shift, it's a horizontal shift. So it shifts it by 3, but horizontal shifts occur in the opposite direction of the sign of the shift. So for a vertical shift, my plus 3 went up by 3. In the horizontal shift, the plus 3 is actually going to pull it backwards by 3. So again, start with our regular 2 to the x that we had in part A with the big end of the exponential function in the upper right. And now I'm going to pull that graph, everything back by 3. So now I'll start with my Cartesian coordinate graph. And what I'm going to do is pretend I have an imaginary y-axis that's back 3. So I'll come back 1, 2, 3 from the origin. And now I have that same shape, except where it transfers from tiny fractions to big output doesn't occur at the y-axis. It occurs back 3 to the left of the y-axis. And now G you have both a horizontal and vertical shift. G says graph the exponential function f of x equals 2 to the x minus 6 plus 4. So the minus 6 is in the exponent and the plus 4 is not. So you have a positive base, positive exponent. So again, you're starting essentially with the graph we had in part A, where the big end, or what I call the big end, it's not a very mathematical term, but the part with a very rapid growth is in the upper right. Now you're going to take that basic graph, and because of the minus 6 with the exponent, you're going to pull it forward or to the right by 6, and because of the plus 4 at the end, you're going to pull it up by 4. So you're shifting horizontally and vertically. So I'll start with my standard Cartesian coordinate graph with the x and y axis, and I'm going to shift forward to the right by 6. So I'm going to come over 1, 2, 3, 4, 5, positive 6, and have an imaginary y-axis that's 6 to the right of the real y-axis. And I have a plus 4 at the end of my function, so that's going to give me an imaginary x-axis 4 above the real actual x-axis. And now I have the same graph that just makes that transfer from tiny fractions to big output instead of at the origin where it does without any shifting to over 6 and up 4 because of the shifting in the function. And part H is also a double shift type of problem, but you're not starting with a 2 to the x, you have a negative. So that's going to flip the graph around a little bit and still shift it. So part H says, graph the exponential function f of x equals negative 2 to the x power and then plus 5, where the plus 5 is not in the exponent, it's on the end of the function. So just negative 2 to the x, going back to part B, that was our graph. So just negative 2 to the x, just to give us a starting point. We have that same shape with a rapid growth part or big end in the bottom right. Now, because of the vertical shift of plus 5, I'm going to pull everything up by 5. So I'm going to start with my standard Cartesian coordinate graph, and I'm going to pull everything up by 5. I'm going to imagine that I have a new x-axis up a height of 1, 2, 3, 4, 5. And now I'll put the same traditional shape that I have here, except everything's been lifted by 5. And finally, part I, the last part, it says graph the exponential function f of x equals 2 to the negative x power minus 1. Again, where the minus 1 is on the end of the function, it's not up with the exponent. So first of all, forget the shift for a minute. Just focus on 2 to the negative x. If you have 2 to the negative x, that was one of the previous parts. It was part C, and the rate of very rapid growth or big end was in the upper left for 2 to the negative x. Now, because of the minus 1 at the end, it's a vertical shift, and it goes down by 1. It's going to pull this graph of 2 to the negative x down by 1. So again, I'll start with the standard Cartesian coordinate system with my x and y axis intersecting, and I'm going to imagine that there's a new x-axis, one lower than the real x-axis, and then I'm going to put the same graph that I had before, like that. So that's a quick freehand sketch of each one of those 9 exponential functions.